Good day, Philippines. Hello, Region 1. Aloha, San Carlinian learners. Airing live from the Mango Bamboo capital of the Philippines, San Carlos City. You're tuning into CCN Broadcast Center, a virtual home of every SDO-SEC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SEC learner. Good day, Philippines. Hello, Region 1. Aloha, San Carlinian learners. Airing live from the mango bamboo capital of the Philippines, San Carlos City. You're tuning into CCN Broadcast Center, a virtual home of every SDO-SEC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SEC learner.
Aloha, Carlos and Carlin learners! Hello, adorable young scientists! Are you ready for another exciting learning adventure in this captivating world of science? That's great! So, join me and let's get mesmerized in the beauty and wonders of the world as we engage, explore, experiment, and investigate scientific concepts and information. I am your science teacher for today, Teacher Rose, right here, live at Carlos and Carlin Network, the pride of San Carlos City Division Broadcast Center, where learners learn best. But before we proceed, please prepare your self-learning module for Quarter 3, Module 1, together with your paper and pen, to keep notes of the important concepts for today's lesson. And our lesson for today is describing motion in terms of distance and time. And young learners, at the end of the lesson, we expect that you will describe the motion of an object by tracing and measuring its change in position, distance traveled over a period of time. So, before we begin, let's try to have a pretest to check whether how much do you know about our lesson for today. Write true if you think the statement is correct, and write false if you think the statement is incorrect. Number 1. Motion is a change in position with respect to a reference point. What is your answer? The answer is true. Number 2. Distance is a measure of how far or near 2 points are from one another. What is your answer? The answer is true. Number 3. In science, distance should always be exact, measured accurately, and based on a standard unit of measurement. What is your answer? The answer is true. And number 4. 1 kilometer is equal to 1,000 centimeters. Is it true or false? What is your answer? The answer is false. And later, we will discover how many kilometers are there we will discover if how many centimeters are there in or kilometers for centimeters. And number 5. Speed is measured in meters per second or kilometers per hour. What is your answer? Is it true or false? The answer is true. In our previous lesson, we learned about estuaries, intertidal zones, and ways to protect and conserve estuaries and intertidal zones. So, let us answer the following questions. What do you call the nurseries of the seas? What is your answer? The nurseries of the seas is called estuaries. And why do you think estuaries are the nurseries of the seas? Estuaries are called the nurseries of the seas because they serve as the breeding ground for many ocean fish. And what do you call the area where the ocean meets the land? Any answer? And the answer is intertidal zones. Intertidal zones are also called foreshore or seashore. Again, let's try this activity. Draw a happy face if the following pictures show conservation of estuaries and intertidal zones, and sad face if not. Number 1. Allowing small animals to live in their natural habitat. So, how do you feel upon seeing this picture? Is it a happy face or a sad face? What is your answer? The answer is happy face. Number 2. Disposing plastic bottles in seas and bodies of water. What do you feel upon seeing the picture? Is it a proper way of taking care of our marine ecosystem? Is it a happy face or a sad face? The answer is a sad face. And how can you help to prevent pollution of our marine ecosystem? It is simply just recycling or avoid throwing plastic bottles in the bodies of water. Number 3. Using fish nets instead of dynamites in fishing. How do you feel upon seeing the picture? Is it a happy face or a sad face? The answer is happy face. And number 4. Plastic bags and trash were left in seashores. How do you feel about that? Is it a happy face or a sad face? Of course, it is a sad face. So, kids, let us throw our garbages in their proper places. Number 5. Participating in cleanup drives in marine ecosystems. How do you feel about that? Happy face or a sad face? Of course, we have a happy face. So kids, did you get all the correct answers? Very good. So, take a look at the pictures again. What can you say about the pictures? Are they all moving? Very good. The pictures show actions or movements like running, biking, and horseback riding. Can you give me some other actions that require movement? Very good. All our activities involve movement. We have to move in order to complete our tasks. And motion will always be a part of our daily life. So, what do we mean by motion? Let's take this picture. How does the ball move? Any answer? Okay. The ball moved because it is kicked by the boy. Is there any force exerted on it? Okay, very good. It is by kicking the ball. So, there is a force exerted on it. So we can say that motion is defined as a change of an object's position as caused by force. And another picture, what can you say about the picture? Very good. The car is moving. And it is said that motion is relative. Why did we say that motion is relative? Let us consider the passengers inside the car. The passengers inside the car do not consider themselves moving because they are just sitting on the car. However, the people outside the car consider the passengers moving because the car changed its position from one place to another. So, motion is a change in position with respect to a reference point. What do we mean by a reference point? A reference point is a fixed place or an object used to determine the position of an object. So, if the reference point is the ground, then the car is moving or the passengers are moving. But if the reference point is the floor of the car, then we say that the passengers are not moving. Take this picture again. So, what can you say about the pictures? Compare the two pictures. Did the pencils move? Alright. It all depends upon the reference point. So, if the reference point is the pile of the books, the pencil changes its position. If the reference point is the pen holder, the pencils did not change position for they are still inside the pen holder. How about this picture, guys? Young scientists, what can you say about the picture? You might say that we have to observe social distancing, right? Am I correct? Yes, Of course, at present, we still have to practice social distancing as well as wearing your face mask in order to protect ourselves from the COVID-19. But here, in our lesson, we are referring to the distance, which is an important factor for measuring motion. And distance is the measure of how far or near 2 points are from one another. It can be measured using different ways such as time, landmark, or body parts. In science, distance should always be exact or measured accurately and based on a standard unit of measurement. The metric system is the world standard for measurement, and it is used by scientists throughout the world. In the metric system, the standard unit of measurement used for distance or length is meter. Again, the standard unit of measurement used for distance and length is meter. However, kilometer is used when the distance is quite far. Prefixes like deci, centi, and milli are used if the length is quite short. Okay, so here it is. We have the bigger units such as the kilo, hecto, and deca. Well, the base unit is the meter, and the smaller units are deci, centi, and milli. So, to convert a larger metric unit to smaller metric unit, let us follow these steps. For example, convert 1 kilometer to meter. So, first step is put 1 on the given unit. So, the given unit is kilometer. And then, step 2, add zeros on the boxes on the right until your goal is reached. So, we have 0, 0, and 0. So, we can say that 1 kilometer is equal to 1,000 meters. To convert a smaller unit to a larger unit, follow these steps. For example, convert 1 decimeter to kilometer. So, again, let us put 1 on the given unit. And the given unit is decimeter. Step 2. Then add zeros on the boxes on the left, and when your goal is reached, put a decimal point. Like this. 0, 0, 0, and a decimal point for kilometer. So, 1 decimeter is equal to 0.0001 kilometers. Is it now clear how to convert units? So, let us remember the following conversion table. 1 kilometer is equal to 1,000 meters. 1 meter is equal to 100 centimeter. And 1 meter is equal to 1,000 millimeter. So let us try to answer this short problem. A man is traveling from town A that is 5 kilometers away from town B. How many meters was he able to arrive? So, what is being asked in the problem? Very good. The answer is, how many meters was he able to arrive if there are 5 kilometers? So let us remember that 1 kilometer is equal to 1,000 meters. So, what do you think is the operation that we are going to use? Is it multiplication or division? Okay, 5 kilometers is equal to n. So let us write this. 5 kilometer over 1 times 1,000 meter over 1 kilometer. Then, cancel kilometer and kilometer. The answer is 5 times 1,000 meter is equal to 5,000 meter. Or, using the table, we can do it like this. Write 5 in kilometer, 0, 0, 0 until meter. So the answer is 5 kilometer is equal to 5,000 meters. Again, we have here another pictures. What can you say about the two pictures? It tells how fast the girl swims. And the second picture tells how fast the athletes run. So, in short, we are talking about the speed. Very good. So, the distance covered by a moving object is affected by its speed or the measure of how fast it moves. The faster it moves, the shorter time it takes to cover a certain distance. The slower it moves, the longer it takes to cover the same distance. So, speed can be calculated by dividing the distance covered by an object in motion by the time spent to cover distance. And this can be expressed as speed is equal to distance covered over time. And speed is measured in meters per second or kilometers per hour. So let us try this simple problem. It takes a fast swimmer about 25 seconds to complete a 50 meters freestyle. What is the speed of the swimmer? So, what is the formula for the speed? Speed is equal to distance over time. And what is our distance? It is 50 meters. How about the time? We have 25 seconds. So, let us write it like this. 50 meters divided by 25 seconds. So, I'll give you 5 seconds to answer it. Time's up. The answer is 2 meters per second. Another example. You went on a car trip to a town in Nueva Ecija. It took you 4 hours to travel a distance of 284 kilometers. What was your average speed? Again, speed is distance over time. And what was our distance? We have 284 kilometers. And what is the time? 4 hours. So, let us write like this. 284 kilometer divided by 4 hour is equal to, again, I'll give you 5 seconds to answer. Okay, the answer is 71 kilometer per hour. Did you get the correct answers? That's great. Again, I have here pictures. What can you say about these pictures? Very good. It tells about the speed limit. And why is it important to follow these signs, the speed limit? Very good. We have to follow these signs in order to avoid accidents. Speed limits or speed limit signs are placed along roads and highways to alert drivers to the maximum speed they are allowed to travel on that roadway. Speed limits are designed to enhance safety by reducing the risks created by drivers selecting the speed they wish to drive. And that's it, learners. So let us try this short activity. Read each situation and tell if it exhibits motion or an object at rest. You can jump if it exhibits motion. You can stand up if it exhibits objects at rest. So, let's start. Number 1, a farmer plowing with the help of a carabao. Is it a motion or an object at rest? The answer is, it is a motion, so jump. Number 2, a cup on the table. Is it a motion or an object at rest? It is an object at rest, so stand up. Number 3, a boy running near the finish line. Is it a motion or an object at rest? It is a motion, so jump. Number 4, a car parked in a parking lot. Is it a motion or an object at rest? The answer is an object at rest, so just stand up. Number 5, blades of fan rotating. Is it a motion or an object at rest? So, the answer is an object at rest. So just stand up. Okay, so let us check now what you have learned in our lesson. So, unscramble the jumbled letter. Number 1, it is a change in position to a reference point. So, what is your answer? The answer is motion. Number 2, it is a fixed place or an object used to determine the position of an object. What is your answer? The answer is reference point. Did you get the correct answer? That's good. Number 3, it is the measure of how far or near 2 points are from one another. So, what is your answer? The answer is distance. And number 4, it refers to how fast the object moves. We have the speed, And how do we get the speed? Speed is equal to distance over time. And number 5. The standard unit of measurement used for distance or length is meter. How about if the distance is quite far? We used kilometer. Again, let's have more. Identify the reference point that determines the presence of motion. So we have here 2 pictures. I'll give you 5 seconds to answer. The answer is road or the ground. Number 2. Convert the following metric units using the table. 8 kilometers to meter. So, I'll give you 5 seconds to answer. The answer is, put 8 in kilometer, 0, 0, 0. So, we have 8,000 meter. Did you get the correct answer? And number 3. Convert the following metric units using again the table. 5 centimeters to meter. So I'll give you 5 seconds to answer. Okay, so let us put 5 in centimeter, 0, and then a decimal point for meter. So the answer is 0.05 meter. Number 4. Pangasinan is 191 kilometers from Manila. How many meters are you going to travel if you want to visit your grandfather in Pangasinan? Again, I'll give you 5 seconds to answer. Okay, so let us convert 191 kilometers to meter. And the answer is 191,000 meter. Because in 1 kilometer, we have 1,000 meter. 191 times 1,000 is 191,000 meters. Number 5. The bus traveled 300 kilometers in 6 hours. What is the speed of the bus? Okay, so the answer is 50 kilometers per hour. And excellent learners, if you got the 5 perfect scores, I'll give you this 3 stars. And for the final part, we have the assessment. Choose the letter of the correct answer. Number 1. How many meters are there in 1 kilometer? The answer is letter D, 1,000. Number 2. Which does not demonstrate motion? A. Ball rolling on the floor. B. Ballerina dancing on the stage. C. Mother walking on the street. Or letter D. Pencil on the table. So, what is your answer? It does not demonstrate motion. The answer is letter D. Pencil on the table. Number 3. Which of the following is the standard unit of measurement used for distance or length? Letter A, foot. B, meter. C, minute. D, second. The answer is letter B. And Number 4. A jeepney travels 120 kilometers in 3 hours. What is the average speed? So, if we get the speed, we have to distance over time. So, letter A, 40 kilometer per hour. B, 8.4 meter per second. Letter C, 15 meter per second. Letter D, 30 kilometer per hour. So, what is your answer? The answer is letter A, 40 kilometer per hour. And the last one. Which of the following demonstrates motion? A, boy jogging in place. B, dog barking at the garage. C, girl running towards his father. Or letter D, boy running on a treadmill device. So, the answer is letter C, girl running towards his father. Okay, young learners, a great job for you. And for our homework, read and solve each problem. I've given you 5 simple problems to solve. And that's it. For our references, we have the Self-Learning Module, Quarter 3, Module 1, and Science Beyond Borders. No copyright infringement intended, and credits to the rightful owner. So, thank you so much for listening, and I will leave you a simple greetings for you. Children or young learners, keep on pushing on your dreams. Keep learning, because at the end, you can make it to happen. Again, I am Rosemarie Gil C. Arboleda from Pangpang Elementary School. Thank you so much and God bless.
Good day, Philippines. Hello, Region 1. Aloha, San Carlinian learners. Airing live from the mango bamboo capital of the Philippines, San Carlos City. You're tuning in to CCN Broadcast Center, a virtual home of every SDO-SEC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SEC learner.